Okay. What we have here is we're going to go through 2014 No Calculator problem number 3. This is a very basic, common free response question on the AP test, in that they give you a graph and they define it as f of x, and they go through and define this function as and define one as an integral. Okay, so without further ado, let's see if we can figure this one out. So let's say we have a function f is defined by this graph from -5 to -4, or sorry, 4. Okay, the graph of f consists of 3 line segments. All right, and is shown above. Let g be the function defined. Now this is really, really important. G is this integral. Okay, so integral. So right here, all right, g of x is the integral from -3 to x of f of t dt. Now, key thing when you're doing this is that you have to apply the fundamental theorem of calculus, and so that because this integral of f of t, all right, that means we are finding this area under the curve, under the curve of f. So when you integrate, you're finding the area of the curve under the curve of f. Okay, from -3 to x, all right, will equal g of x, so values of g of x. Okay, so this integral means we're finding the area of the curve of f of x. Okay, now we also know fundamental theorem of calculus states that when we take integrals also mean antiderivatives, and when you take the derivative of an antiderivative, you get the function inside. So we know that g prime of x equals f of x. All right, g prime of x equals f of x. So all this stuff is going to help us out in solving these different problems. So we're asked to find what is g of 3. Okay, so when you're ever given a problem like this, think about g of 3. Okay, in that we're going to plug in this, and g of 3 should equal the integral from -3, and since this is g of x, and we're going to plug 3 in for x, for f of t dt. Okay, so what does that mean? That means we're finding the integral f of t from -3 to 3 is that we're finding the area, because remember, integrals mean area. The area from -3, all right, so 1, 2, 3, -3 to 3, 1, 2, 3, all right, of this function. So I want to find, in order to find this value, I have to find the area of this triangle, because the area of this triangle is 1, 2, 3, 4, 5. All right, so 1/2 times 5 times the height, which is 1, 2, 3, 4 times 4. Okay, so we have that plus the area of this itty bitty part right here. Okay, so we have that one right there. Okay, and we have this. All right, now whenever you have an area underneath, that's going to be a negative area. So that means we're going to have a negative, all right, 1/2 of 1 times, I believe this appears to be 2, all right, 2. And we could find this out by looking at the slope, all right, of this, and we can find out, yes, it's going to equal 2. All right, so in doing so, what we have is this cancels out. We're left with 2, so we have 10 minus 1, which should be 9. So this value is 9, so g of 3 equals 9. All right, that's cool. Now, next thing is we're going to continue on this problem, and says, on what open interval contains -5 to 4 is the graph of g, both increasing and concave down. All right, both increasing and concave down. All right, so where is it increasing and concave down? Well, we know that g, all right, g is going to be increasing when, all right, g prime, which equals f, is going to be greater than 0. And you know it's concave down, all right, g is concave down, all right, when, all right, g is decreasing, or sorry, g prime is decreasing, or if you know that where g is prime is decreasing, all right, or where f is decreasing. Okay, and that's what we have there. So where is that occurring? Okay, where is that occurring? So where is f going to be positive and also decreasing, and f is decreasing. So f is positive on this entire interval. So looking at this, and going to be decreasing, well, it's decreasing here, and it's also decreasing there. All right, And so we have intervals from -5, all right, -5 to -3. And we have intervals from 0 to 2 is where this is going to happen because G increases when G prime is, which equals F is greater than 0, and where G concave down when G prime is less than 0. And that happens on this interval right there. Cool. Next one is let function h be defined by h of x equals g of x. All right, over 5x equals h prime. Find h prime of 3. Okay, so this one I'm going to find h prime of 3. I'm going to change my color here. All right, h prime of 3. So I'm going to put 3c down here. So h of x equals g of x, all right, over 5 of x, or 5 times x. So if I want to find h prime, well, h prime of 3, I first want to find h prime of x. We have to use quotient rule. So we take the derivative of the top, which is g prime of x, times the bottom, which is 5 of x, minus the derivative of the bottom, which is 5, times the top, which is g of x, all over, all right, we have 5x, that quantity squared. Okay, so now we're going to use this to find out g of 3. So now I'm going to plug this in here. So g prime of 3 times 5 times 3, which I'm just going to put 15 in there, minus 5 times g of 3, all over 15, the quantity squared. Okay, so let's find this out. What is this going to equal? Well, g prime of 3 equals, actually, if you recall, g prime equals f. So we're really looking for f of 3 times 15 minus 5. And what's g of 3? Well, g of 3 would be the integral, all right, from -3 to 3. All right, so that would equal the integral from -3 to 3 of f of t dt. All right, all over 15 squared. Okay, so now let's find all this stuff out. Well, f of 3, this is f of 3, 1, 2, 3, all right, is going to be right there. Okay, so f of 3 is going to be 2. All right, so we're going to put 2 here. Okay, so 2 times 15, which is 30, and minus 5 times, well, what's this going to be? Well, that right there, my friends, is going to be, we just found that out right here, which is 9. That's 9. All right, that's going to equal 9. And so we're going to add that times 9 all over 15 squared. 15 squared. Okay, and so we're going to simplify this. We have 30 minus 45 all over 15 squared, and we have this right here, which is going to be, appears to be negative 15 over 15 squared, and that divides out to be equal to -1 over 15, I believe. All right, that's our value, that's the derivative. So that is what we know is going to equal h prime of 3 right there. Okay, cool. Well, let's go for one more, and let's see how we do this final one. All right, D, it says the function p is defined by this, okay? Find the slope of the tangent line to the graph of p at the point x equaling 1. Okay, so in order to figure this out, so that we're going to find the slope of the tangent line to the graph of p at x equaling 1. So essentially, slope of a tangent line of p is we're going to figure out what it is p prime at -1. That's what we're looking for. So very similar to what we had up here, except now we have f p prime. So how do we do this? Well, first off, we're going to find this. So let's just find p prime of x. Well, p prime of x is defined by f of x squared minus x. Well, this is, we're going to use the chain rule, the chain rule here. So we're going to have derivative of the outside. Well, the derivative of f is going to be f prime of x squared minus x times the derivative of the inside, which is 2x minus 1. Well, now, once we have that, using chain rule, we're then going to figure out what p prime of -1 is. To find p prime of -1, I'm going to plug in -1 in here. -1 squared is 1, so -1 squared minus -1. All right, And then we're going to put that in there. So 2 times -1 minus 1. All right, so let's see. We have 1 plus 1 is 2. So we have f prime of 2. And then we have 2 times negative, which is -2 minus 2 is -3. And that's going to equal p prime of -1. Well, what's f prime of 2? Well, f is here. F prime means I'm finding the slope. We're finding the slope of f at 2. All right, x equaling 2. So really, it's kind of cool is that at this point right here, x equaling 2, we're finding, all right, this slope of this line. All right, so what, and this slope of this line is constant. So what is this slope going to be? Well, we have 1, 2, 3, 4. So rising 4, running 2. But this is going to be going down. So it's going to be rise over run. So it's going to be -2. So, all right, in this case, we know that f prime of 2 equals -2, along with all the other values in this. So it's going to be -2. So we'll come back down here, and we'll have this right there. So this is going to equal -2 times -3, which gives us 6. So p prime of -1 appears to be 6. Hopefully I did all my math right. All right, because I am known to kind of screw up once in a while when I'm doing some values. But this, yeah, so this is where we're combining fundamental theorem of calculus right here. We're using areas underneath the curve to find the integral and for values of a function. All right, and that's what we can do when we find when functions are equal to an integral. So to remember that that equals the antiderivative or the area of the curve. So we got to apply that principle. Using a lot of derivatives, all right, to help us figure this out and going back and forth with that, and then finishing off with that. So hope this helps you out in solving some other problems similar to this on other AP free response questions. Good luck and God bless.